In this video, we'll be starting to talk about the rational zero test. Now, the rational zero test says that if we have a polynomial of degree n, like so, and if it has integer coefficients, then every rational zero, and this is an important word here, that is every fractional zero, has the form p over q, where p is a factor of a0 and q is a factor of an. So with that said, there's a big warning here, which is the following. This gives only possible rational zeros. So it's good in that sense because of the fact that there's no rational zeros that could sort of escape this list that we'll make. However, not every possible rational zero needs to even be an actual zero. Also, there may also be some irrational or complex zeros in this, okay, that we're missing, okay? So for instance, let's try an example. So here, the rational zeros of this would be, well, here, p has to be a factor of a0. The factors of a0 are 1 and -1. The factors of an, which is my leading term, are plus or minus 1 as well. Well then, let's write out all the possible fractions of those. So the only possible rational zeros are plus or minus 1, right? However, if you plug those in, let's try testing out to see if either of them is. Well, here we have f of 1 is 1 cubed plus 1 plus 1, which equals 3. So that's not a zero. And f of -1, if we plug -1 in, we get -1 cubed is -1 plus another -1 plus 1. That would give me -1, which is also not a zero. So actually, this has no rational zeros. However, if you would look at, by looking at the graph, and if you look in the book, it shows this. Looking at the graph, you see it does have a zero. It actually does have a real zero, but it must have an irrational one if that's the case, because we've shown it has no rational ones. So now let's have you try. Let's go ahead and find, if possible, the rational zeros of f of x equal x cubed plus 2x squared plus 6x minus 4. On the count of 3, I'll reveal the solution. 1, 2, 3. So here again, we get no rational zeros. Our possible rational zeros, by figuring out what p and q can be using the factors, are plus or minus 1, plus or minus 2, and plus or minus 4. Well, let's check all of these. Checking 1, -1, 2, -2, 4, and -4 by plugging all of them into the function, we never get any zero out, and so because of that, there are actually none of these are actual zeros, so there are no rational zeros. Well, let's try another example. So let's go ahead and find the rational zeros of f of x equal x to the 4th minus x cubed plus x squared minus 3x minus 6. All right, first, let's go ahead and figure out what could be, what our possibilities are. Well, here, p has to be a factor of 6. That's plus or minus 1. Positive 2 and -2 are both factors. Positive 3 and -3 are both factors. And positive 6 and -6 are both factors. Q, on the other hand, the factors are positive 1 and -1. Well, p over q, then, the possible zeros are p over q, possible rational zeros are plus or minus 1. Let's write it this way. It's the way WebAssign likes it. 1, 2, 3, 6, -1, -2, -3, and -6. And so now we get to have the fun of plugging each of those in. So let's start testing. Testing, we have that plugging, if we try f of 1 in, we would end up with what? 1 minus 1, which is 0, plus 1, which is 1, minus 3, which is negative 2, minus 6. Well, let's just go ahead and use calculator. Hopefully, if you have a fancy scientific calculator, this will this becomes easy because you can use the memory to help you. 1 to the 4th minus 1 cubed. Actually, I like to do the negatives first. Negative 1. So f of negative 1 cubed plus 1 squared minus 3, 1 minus 6, which gives negative 6 for f of negative 1. F of negative 2, plugging that in, you get 2, 2, whoops. That should have been a negative before. Let's go up a line, make sure I did that right. I didn't. We actually do get a 0 out of negative 1. Well, look at that. That's exciting. And what that means is that if negative 1 is a 0, then that tells me that 1 is a factor, right? So plugging x plus x minus negative 1, which equals x plus 1, is a factor. Well, then we can synthetically divide out, right? Synthetically dividing out, we have a negative 1 here, we have 1, negative 1, 1, negative 3, negative 6. 1 comes down, negative 1 times negative 1, times 1 is negative 1, negative 2, positive 2, 3, negative 6, positive 6, 0, of course. Well then, if that's the case, what we now have is, we've now factored out x plus 1, and now what we have remaining is x to the 4th, so write that down. We have x to the, we have x cubed minus 2x squared plus 3x minus 6. This, we can find zeros of this by factoring by grouping now. We have x cubed minus 2x squared plus 3x minus 6 equals 0. Here, common factor, x squared, x minus 2, plus, pull out a 3, x minus 2, and hey, those are the same. Because those are the same, we can now pull out them as a common factor, x squared plus 3, and then the common factor, x minus 2. Well, so if that's the case, then we now know this gives us x squared. This is going to give us the zeros, x equal plus or minus square root of 3i. But those are irrational. Those are not rational, right? Not rational. However, this is a rational 0. That gives the rational 0 x equal 2. So putting them all together, we get that the only rational zeros are negative 1, which we divided out, and 2. So now it's time to have you try an example. Go ahead and find the rational zeros of x cubed minus 15x squared plus 75x minus 125. On the count of 3, I'll reveal the solution. 1, 2, 3. So here, you may, starting sort of to explain solution 2, you may have said, oh, well, I could try factoring by grouping. If you try factoring by grouping, it's not going to work out. There might be a way to kind of arrange it to get it to work, but it's kind of a waste of time and it's not at all obvious. So instead we start trying to guess some zeros. Here, this is our list of rational zeros. Trying out each and every one of them on my calculator. These are the answers I got from plugging them in. We see x equal 5 as a 0, and that's the only one of these that gives us a 0, so only x equal 5 is 0. However, if you had started guessing and you'd gotten it as a 0, you may have said, oh, is there a way to proceed from there once I know that instead of having to check all the other ones? Well, yes. You then know that x minus 5 is a factor. I did this in the last example. X equal 5 as a x minus 5 is a factor, so we can synthetically divide out and get this. That is, this would be x squared minus 10x plus 25. That factors as x minus 5 times x minus 5. Since x minus 5 already was a factor, what we've really done is shown that f of x factors evenly as x minus 5 cubed. You probably could also do this if you noticed, well, yeah. Maybe you could actually notice that on your own, just using algebra and factoring. I didn't notice it. But anyways, that shows you why x equal 5 is the only 0. In fact, there are no irrational zeros at all. X equal 5 is just a repeated 0 of multiplicity 3. If you'd like some more practice in working with the rational zero theorem, rational zero test, which we'll do in the next, we'll do some more examples in the next video. But in the meantime, try working from the book on page 162, numbers 3 and 15 through 24.